Good evening, everyone. Today we are solving a problem of cable system. We are given this cable system and we are asked to calculate the maximum force. And the maximum force could be in any of the three cable A, B, BC, and CD. So you may be tempted to use the method of equilibrium to solving the reactions at A and D, but that would be of no use really, because the forces in this cable are tension forces, and so they are pulling, and so your area of interest is where the loads are at the joints, and so that's why we are going to use the method of joint at point B and point C. So let's start. So let's consider joint B. So for lack of space, let's use the same diagram and introduce a cut here. So imagine a free body diagram of this joint. So you want to do the sum of forces in this joint. All right, the sum of forces in this joint. So sum of forces at joint B, sum of horizontal forces, sum of the horizontal forces at joint B is going to be, now, so we have this one is negative. Our orientation is such that from this point to the left is negative, and from this point to the right is positive. So it's going to be negative force, and it's going to be 4. We have 4 by 4. So it's going to be 4 divided by square root of 32. How do we get 32? You get 32 by saying 4 square plus 4 square. All right, that gives you 32. All right, so you get that. You got the 32, and that is FAB, and like I said, it's negative. So the next horizontal force at joint B is positive, as you can see from this diagram here, and it's going to be, the horizontal on this line is 8 feet, and the height this way is 2 feet, because you see this is 4, this is 6, so the difference between this 6 and this 4 is 2. So you are going to say 8 divided by square root of 68. How do we get 68? The same way, you have 8 square plus 4 square. All right, you're going to get that. All right, and that is FBC. There's no any other horizontal force at this joint. We have this and we have this, so that equals to 0. All right, so if you simplify this, that will become FAB, let's move this to this side, will become 0.97 FBC divided by 0.707. This value here is this, and this value here is this. Okay, if you further simplify it, that will give you FAB rather, is going to give you 1.372 FBC. Okay, so you got one equation, so that's our equation 1. So that's equation 1 for this joint. So let's develop the second equation. The second equation is going to be, you do the sum of the vertical forces at the same joint. So some of the vertical forces are the same joint. Some of the forces in the y direction. So this force here, as we could see, is positive, going from this point going up. Orientation is positive, and going down is negative. So that is FAB will also the same way be. We already know what this value is. 4 divided by square root of 32 is 0.707 FAB, and it's positive. Then over here, the force FBC is coming down, it's negative. So it's negative, and it's going to be 2 over square root of 68. So that will be 2 over square root of 68, and that will be FBC. And then we have one force, applied force at joint B, and it's 20 kips, and it's negative. So negative 20, 20. Everything becomes 0. So when you simplify that, this whole thing is one single line, but because of space. When you simplify that, you are going to have F in terms of FBC, for FBC, is going to be F AB will be is going to be 0.343 FBC plus 28.3. All right. So you're going to have that value. Okay. So now you notice that, so that's our second equation. That's our second equation here. We have the first equation and we have the second equation. So when you put the two equations together, you put these two equations together, let's just do that quickly. That will be 1.372 FBC equals to 0.343 FBC plus 28.3. So the rest here is arithmetic. When you do this, you notice that it's FBC on both sides. So if you solve for FBC, your FBC is going to be 27.5. 27.5 kips. Okay. So once we know BC, you are able to solve for AB, because all you need to do is to substitute this value of FBC in here, and then you're going to have your FAB to be 37.7 kips. Okay, so we have solved for two of the member, force FAB, which is from A to B, and force BC, which is from B to C. So we'll continue on the second part. We're running already on the video.